Hello, beautiful people, and welcome. In this video, we are preparing for our unit test. Now, on this test, we will have factoring and solving equations. As always, if I make a mistake, please let me know where the mistake occurs so that way I may learn from it and you may learn from it as well. Let's jump in with factoring. Let's start with factoring when our leading coefficient is 1. Now, leading coefficient is the number out in front attached to the highest exponent here. So in this case, n does not have a number in front of it. That means that leading coefficient is 1. We are using the guess and check method. So we're having our two bubbles. We want two numbers to multiply to 35 positive and add to a negative 12. Now you want to list out the factors of 35 and see which ones give you a negative 12. So I know like 1 times 35 is 35. I also know negative 1 times negative 35 is also 35. So don't forget your positives and negatives. So I'm also thinking 6 times 5 is 30. So let's do 5 times 7, not 6. 5 times 7 is 35, and 5 plus 7 is 12. So my factors here are going to be 5 and 12. Excuse me, 5 and 7. And I want both of them to be negative because if I have negative 5, here's my thinking bubble, times negative 7, that gives me a positive 35. And negative 5 plus a negative 7, that gives us a negative 12. Moving on to this one here, this is our A is not equal to 1. Step number 1 is to identify if you have a GCF. So greatest common factor is anything in common between 21, 177, and 210. I'm going to see if 177 is divisible by 21, and it is not. I'm also thinking maybe 177 divided by 7, that also is not divisible. What else? And I'm thinking 21 since it's the smallest number. See if we can pull anything out of 21. And let's see, 7 times 3 is 21. So let's see if 177 can be divisible by 3, and it can be. So I'm going to pull out a 3. That means 21 divided by 3 is 7. 177 divided by 3 is 59. And 210 divided by 3 is 70. Now, I'm going to bring down the 3 into my answer bubble so I do not forget it. Here, I'm going to use the slip and divide method. So you're going to take 7 and you're going to multiply that by your constant, which is 70. So 7 times 70 is 490. And now I'm going to use my guess and check method. So I want, here's our thinking bubble. I want two numbers that multiply to a positive 490. And I want those same two numbers to add up to a negative 59. So here's our guess and check method. So it might take us a little bit. So I'm thinking 490 divided by 49 is 10. So if we do, I'm going to switch here to a pencil just in case I need to erase it. So if I do 49 and 10, 49 times 10 is 490. But when I add 49 and 10, that gives me a positive 59. I need a negative, so I'm going to make both of these numbers negative. I'm going to zoom in just slightly so you guys can see that. There we go. So we have our two factors of negative 49 and negative 10. So I'm going to write my bubbles here. And minus 49 and minus 10. Now at this point you are not done because we did not have a leading coefficient originally of 1. We had a leading coefficient of 7. Now this is after I removed the GCF. Because we had a leading coefficient of 7, I'm going to divide my factors by 7. If you can simplify the fraction, do it. Sometimes it will remain a whole number, sometimes it will stay a fraction, just be simplified, and sometimes you cannot simplify the fraction. 49 divided by 7 is 7, so I have n minus 7. Here I have 10 divided by 7, which you cannot do, it cannot be simplified. So I'm going to take this denominator, I'm going to bring it back out here, and that's going to become our new coefficient for the n, and the numerator stays behind. So I'm going to take these two factors, I'm going to write it in my answer bubble. So my answer for this question is 3 times n minus 7 times 7n minus 10. Moving on to the difference of squares. Now, the difference of squares is a binomial, meaning you will see 2 terms instead of 3 terms. When you see 2 terms, double check that that middle symbol is a minus. If it is a plus, you cannot do anything with it, and you write non-factorable. Here it is minus and minus, so we are good with these 2 examples. What you're trying to do is you're trying to see if the first and the last are perfect squares. So every single thing in here needs to be a perfect square. So 4 times 4, so 4 squared is 16. X times x, so x squared is x squared. And 3 times 3, which is 3 squared, is 9. Combining these 2 bubbles, I have 4x squared minus 3 squared. So we have this being our A, this being our B, and your answer is going to look like this. So A plus B times A minus B. And that is it. Now, if you have a GCF, make sure that is your step number 1. I did a mental check. 16 and 9 do not have anything in common, so we could not do it. Notice here I have a 20. Just kidding, that's not a 20, that's a 50. 50 and 18. And 50 and 18 do have something in common. It is 2. So I'm going to pull out GCF first. So I'm going to say 2 is being pulled out, which gives me 25x squared minus 9 left over. Now notice I still have a binomial, 2 terms with a minus on the inside. 25 is a perfect square, x is a perfect square, 9 is a perfect square. I'm going to bring this 2 down in my answer bubble so I don't forget about it. So I have 5 squared times x squared, and here I have 3 squared. Again, make sure you put your bubbles together. So I have 5x plus 3 times 5x minus 3. On to the square of a sum, square of a difference. Now, there are other methods to do this type of question. So if you want to do a slip and divide method, that is fine. I'm going to show you a quick and easy way to identify patterns of a square of a sum, square of a difference. So if you rather do it this way, that's fine. However, you still can do the slip and divide method. So for example, step number 1 is GCF. I have a 9, a 30, and a 25. 9 and 30 do have 3 as a common factor. However, 25 and 3 don't have anything in common. So there is no GCF. Notice that 9 is a perfect square. Notice that 25 is a perfect square. Also notice that x is a perfect square. So just like in our previous example, we're going to write this as perfect squares. 3 squared times x squared. Here I'm going to write it as 5 squared. Again, combine your bubbles just like before, 3x squared. Here's 5 squared. Now, you're going to do a mental check for your middle term. Your middle term has to be 2 times, it's always 2 times, your A, which is your bubble here, and your B, which is your bubble here. So you have 2 times 3x times 5. If that equals to this middle term, then you have this pattern and you can use the answer here. So 2 times 3 is 6. 6 times 5 is 30, and I have 1x, so this is 30x. So it does check out. So what does that mean? That means for my answer, I'm going to have one bubble. It's going to be squared. There is no GCF for this example. And you're going to take your A, you're going to take your B, you're going to write it out. Now the symbol in the middle, it's not always plus minus. What that means is it's either going to be a plus or it's going to be a minus. It can't be both. So you're looking at the symbol in front of your middle term, which is a minus, and that's going to be the symbol that you take here, and that's going to be your answer. So a much quicker way than slip and divide. However, this only works if you have a perfect square for your first term and a perfect square for your last term. Let's try this one more time. I have an 18, 16, and a 50. Notice 18 is not a perfect square, 50 is not a perfect square. However, 18, 60, and 50 have a 2 in common. So I'm going to pull out the GCF of 2, which means I have 9n squared plus 30n plus 25. I still have a trinomial. I'm going to put this 2 in my answer bubble so I do not forget about it. I do have a trinomial, 1, 2, 3 terms. This first term has a perfect square of 3 and n squared. This last term has a perfect square of 5. Again, mental check. 2 times 3n times 5 is that 30, not 60, 30. 3 times 2 is 6. 6 times 5 is 30, and it does check out here. So that means I'm going to write one answer bubble, which is 3n and 5. Where do those numbers come from? This is your A, this is your B. And what symbol do I do in the center? And that's going to be the symbol that you have on your middle term. In this case, it is a plus. Do not forget your square, as there are 2 of those. We're just combining them into a perfect square. Now, there is one more way of dealing with A is not 1, so your leading coefficient of not 1. This is called the grouping method. Again, you still can use the slip and divide method that we were previously shown. However, this is another method if you wish to use it. GCF 2, 1, 36, no GCF. Step number 2 is just like we did before. Take your leading coefficient, divide by your constant, which is 36. So 36 times 2, 36 times 2 is 72. So I have m squared minus m minus 72. So I still want 2 numbers to multiply to 72, but add to a negative 1. And so my factors are going to be, I'm thinking, here's my thinking bubble, 8 times 9. 8 times 9 is 72, but I want a negative 1 and a negative 72. So that means I'm going to have a negative 9, because 8 plus a negative 9 gives me negative 1. Okay, this is where it gets different. You're going to rewrite your original given equation. So this one here, you're going to rewrite it. And you're going to do what's called split the middle term. Here is your middle term. I'm going to split it in half. And I'm going to write the factors that I've identified, 8 and 9, but I'm going to be very strategic in how I write them. I want this first leading term to have something in common with the first factor that I'm going to write. So does 2 and 9 have something in common, or does 2 and 8 have something in common? I believe 2 and 8 have something in common. 9 and 36 have something in common. So I'm going to write 8 and 9. Remember, 9 was a negative. I am also going to write in the variable, in this case, m, next to my 2 factors. So what you end up having is 2m squared minus, just kidding, this is a plus 8m, and here you have a minus 9m minus 36. And you're kind of almost done. So what you're doing now is you're grouping. Just like the name implies, you are grouping the first 2 and you are grouping the second 2 terms together. From your first grouping, you're going to remove a GCF. From your second grouping, you're going to remove a GCF. So 2m squared and 8m have 2m in common. That gives me m left over plus 4. Here, negative 9m minus 36, what does that have in common? I have a 9, no m, so m stays over, minus 4. Now notice, 9 times m is not 9m negative. That's positive. So that means this 9 that I pulled out needed to be a negative. Negative 9 times a negative 4 is not a negative 36. So that means this needs to be a positive. Your objective with grouping is to get these 2 bubbles to be identical. So these 2 need to be exactly the same. If they are not the same, then you cannot do the following steps. The ending of grouping is you're taking your 2 GCFs, in this case 2m minus 9, you're going to put that together in one bubble. Your second step is to take your 2 identical groupings, which is the m plus 4, and you're going to write it one time here in your answer bubble. If you had a GCF, you would also write a GCF out here. In this case, that is it. So here's another way. I'm not going to do another example. If you wish to know a little bit more about grouping, definitely reach out to me. But slip and divide method for my class is more than enough. If you prefer grouping, do that as well. Moving on to solving quadratics. Let me shift this up. The first step to solving quadratics is by factoring. So all of these methods that we just went over are fair game. So step number one is you're going to set this equal to a 0 if it's not already a 0. Step number two is you're going to factor. In this case, our leading coefficient is 1, so we're going to use the guess and check method. Two numbers that multiply to 21 but add up to 10. I'm thinking 7 and 3. 7 times 3, let me double check, in fact is 21, and 7 plus 3 is positive 10. So that means I got p plus 7, p plus 3. Now again, what's our objective? What's our goal? And that is to solve for the variable. Our variable is p, so we're going to set both bubbles equal to 0 and solve, just like we did in integrated math 1. So we have a minus 7, p is equal to negative 7, and a minus 3, p is equal to negative 3. Now it is your choice if you want to write your answers like this, or if you want to combine them and say p is equal to negative 7, comma, negative 3. This is not a coordinate point, you are just listing the values. To example number 2. In example number 2, I already circled it, but notice you have a plus here. You have an 8, a 40, and a 32. That means we have a GCF, and I believe our GCF is 8. So if I pull out 8, I have v squared left over, plus 40 divided by 8 is 5, so I have 5v, and I have 32, which is 32 divided by 8 is 4. So 8 is going to be, I'm going to just bring it down here, that's going to be in my answer here for my factoring. And here I have a leading coefficient of 1, so I'm going to continue using guess and check. Again, our equation is equal to 0 as we are trying to solve. So two numbers that multiply to 4 but add up to 5, I have v plus 1 and v plus 4. Now each bubble gets set equal to 0. So I have 8 equal to 0, v plus 1 equal to 0, and v plus 4 equal to 0. Here I have v is equal to a negative 4. Here I have v is equal to a negative 1. And now here, take a look at this. Is there a variable for us to solve? Is there a v in here? No, there's no variable. There's nothing to solve. Also, is 8 ever the same thing as 0? Having $8 or having no money are very different. So this is not true. So you do not include, if it's just a number, you don't include it. Only variables. So we have two solutions here. Next one we have is taking the square root. Now taking the square root works when you have only one variable, for example b squared or m squared. It doesn't work when you have something like a trinomial where you have something squared and then p by itself. So like p squared and p, those are two different things. So we aim to have only one variable. Now the variable could be separated and you'd have to combine it, but it has to be the same like term. Let's go ahead and get b squared by itself. So I'm going to divide 81. B is now equal to, b squared is now equal to 64 divided by 81. I'm going to take the square root, both sides. Remember, there's a small little 2 here as my index. This 2 and this 2, they go away. B is then equal to plus or minus always square root of 64 over 81. Now, I'm noticing that I have perfect square on top and a perfect square on the bottom. So I can continue to simplify by taking the square root of 64 and taking the square root of 81 separately. I'm going to shift this up. So I have a plus or minus 64 square rooted, that's 8. 81 square rooted, that's 9. And we are done with our equation. Moving on to example number 2 for taking square root. Notice that there is two things attached to m squared, so I'm going to add 10 to both sides. So I have 192 left over. I have 3 times m squared. Dividing by 3 both sides, m squared is equal to 192 divided by 3, which is 64. Taking the square root of both sides, plus or minus always. So these two go away. They undo each other. Square root of 64 is 8. I have a plus or a minus. All right, moving on, we got 2 more methods to go over. First one is completing the square. Completing the square works when factoring doesn't work. It's pretty great. Step number 1, you're going to get rid of that constant. You're going to move it to the other side. So I have r squared minus 20r. And on the side, I have a positive 61. Taking your middle term, in this case, a negative 20, you're going to divide that by 2, and it's always divided by 2. It doesn't matter what that is. So that is a negative 10. Then you're going to square that number, which is 100. This 100 is now what's going to be added to both sides. So I have plus 100 here, plus 100 here. So what am I left with? I'm left with r squared minus 20r plus 100, and that's equal to 161. On this side, we're going to factor this. And what's really cool is remember that negative 20 divided by 2, that was equal to negative 10. That is our factor. So this negative 10 is what I'm going to write in here. And that is going to be squared, and that's equal to 161. Taking the square root of both sides, I have r minus 10 squared, again square rooted, and I have a plus or minus square root of 161. Now is 161 a perfect square? Let's check. It is not a perfect square, and that's okay. So you have r minus 10, these two and these two go away, plus or minus the square root of 161. And I am running out of space, so I'm going to move forward. We're going to omit our example 2. We're going to get rid of this example so that way I can finish this one here. I'm going to bring it back up. So I have r minus 10 is equal to plus or minus the square root of 161. You're going to separate this out into 2 separate equations. First one is r minus 10 is equal to positive 161 square rooted. Second one is r minus 10 is equal to a negative 161 square rooted. We're going to add 10 to both sides. Now you're adding it outside of the parentheses, outside of the square root. You're not actually going inside. So I have r is equal to 10 minus the square root of 161, and r is equal to 10 plus the square root of 161. And that is your answer. You're going to have 2 answers. And that is completing the square. Very last one here is the quadratic formula. So for the quadratic formula, you have to know what the quadratic formula is. Before we do that, let's say this is our A, this is our B, and this is our C. We were talking in class about the discriminant. So the discriminant tells us the quantity of solutions it's going to give us. It doesn't tell us how many solutions it is. So let's find the discriminant first. And the discriminant is the square root of b squared minus 4ac. Now, where does this come from? This comes from the quadratic formula, and this is the number of solutions it gives us. So let's plug this in. b is negative 7, 4 times a, which is negative 6, and c, which is 68. Big numbers, that's okay. We get to use our calculator. So I get 49, again, square rooted, 49 minus 68 times negative 6 times negative 4 gives me a positive 1,632. I'm going to add that to 49, and I get the square root of 1,681. And I'm going to take the square root of that, and that gives me 41. And so what does that mean? This is not our answer. This is just the discriminant. And what that tells us, since it's positive, that tells us you're going to have 2 solutions. Now it's our turn or our chance to find out what those solutions are. What are they really? So we're going to go back in here and write out our quadratic formula. So it's a negative b plus or minus the square root of b squared minus 4ac divided by 2 times a. Now you already know what this section is. Let me highlight it so you guys can see. You already know what the discriminant is. Notice that these are the same. So if you want to do it off to the side, you can. Or you can plug in your numbers again. So I'm going to choose to plug it in. So I have plus or minus square root of, that wasn't 4, that was 41. And that was after we already took the square root. So I'm going to put 41 here, divided by 2. A is negative 6, and B was negative 7. This was a negative 7. So you have 2 negatives here. So what do we have here? This should be a negative 7. So I have a positive 7 plus or minus 41 divided by negative 12. Now here, and I am running a little bit out of space, so I'm going to shift to another sheet of paper. I'm going to rewrite this one more time. So I have a negative b plus or minus the square root of b squared minus 4ac divided by 2a. Negative b is negative 7, plus or minus the square root of negative 7 squared minus 4 times a, which is negative 6, times c, which is 68. All of this is divided by 2 times a, which is negative 6. Now we have positive 7, because a negative times a negative is a positive. I have a positive 7 plus or minus the square root of 1,681. This is divided by negative 12. So I have 7 plus or minus the square root of, I don't need a square root. I already did the square root. So this is 41 divided by negative 12. So now we separate this out into 2 separate equations. One of them is a plus, one of them is a minus. And this is a 7. So 41 plus 7 is 48 divided by negative 12. And that gives us negative 4 is equal to x. And then this one here, 7 minus 41 is 34 negative divided by negative 12. And that gives us 34 divided by 12. And that gives us 17/6. And that's equal to x. All right, beautiful people, that is it for your review for your practice test. Let me know if you have any questions. And as always, thank you so much for watching our video. Bye.